The toughest problem on this last written homework assignment was probably the last question. And so I wanted to create a quick video for anyone who wants a more detailed explanation for this problem. So basically, we're asked to analyze the solution set for this system of linear equations where we don't have values for all of these coefficients in the third equation. Instead, we have these expressions of some constant k. So I went ahead and set up the augmented matrix corresponding to this system here, and the first step in the row reduction. So we've already got a 1 in the top left corner. I like to work down from there, so I would get a 0 in this position using the operation I wrote here. Okay, so I'm going to start from that point, and I'm going to have to slide the screen over a little bit. And write the new matrix here. So only row 2 is changing. Actually, I might do something here as kind of a shortcut. Okay, but so let me copy down row 1 the way it is. I'm just hoping I'm going to have enough room here. Okay. Second row, so I've got negative 2 times 1 plus 2, so that's 0. And then negative 2 times negative 2, so that's positive 4, plus negative 3, so that's positive 1, so that's convenient. And then negative 2 times 1, so negative 2 plus 4 is 2. And then negative 2 times 3, so negative 6 plus 5 is negative 1 here. Yikes. Sorry. Okay, and I'm going to go ahead. So I'm going to do an operation on the third row as well in this same step, just so this video isn't going on and on with me just copying down matrices. So just doing the one step, I would now copy down row 3 the way it is. So 3k minus 5, k squared plus 5, and 8. And then the next target would be to get a 0 in this position. So I'm going to go ahead and write that step as well. So I would do negative 3 times row 1 and add that to row 3. And so the arithmetic gets a little tougher here since we have these expressions of k in row 3. So I'm going to write out scratch work for this operation over here. So negative 3 times row 1 would be negative 3, and then positive 6, negative 3, and negative 9. And we're adding that to row 3, which is 3k minus, gotta write this small, k minus 5, k squared plus 5. It's probably going to be illegible here, sorry. I'm still using that stylus that does really not work well. And then 8. Okay, so when we add that up, negative 3 and negative 3. 6 plus k minus 5 would be k plus 1 when you combine the 6 and the negative 5. K squared, and then we've got positive 5 and negative 3, so that's positive 2. And then negative 9 and 8 gives us negative 1. So let me scoot this over so I can write it more neatly over here. So the new row 3 is 0, k plus 1, k squared plus 2, which I'm sorry, I'm going to write sideways here because I didn't leave myself enough room. K squared plus 2, and then negative 1. Okay, I paused and rewrote that. I couldn't live with that sideways k squared plus 2. Okay, so the first 2 rows are, we're in pretty good shape as far as row echelon form, but we should continue to reduce here and try to get a 0 in this position. So in order to get a 0 in that position, I want to do, opposite of this number, so negative k plus 1 times the 1 in this position, so times row 2, plus row 3. The operation that we need next is negative k plus 1 times row 2 added to row 3. Okay, so I paused to set a few things up. This is the operation that we want. So I've written negative k plus 1, whoops, times row 2. I'm going to remake this video later on. But negative k plus 1 times row 2 is what I wrote here. So negative k plus 1 times 0 gives me this 0. Negative k plus 1 times 1 gives me negative k plus 1. Negative k plus 1 times 2, so I just wrote that as negative 2 k plus 1. And then negative 1 times negative k plus 1 would give us positive k plus 1. And then here I just copied down row 3 the way it was. So now I want to combine those terms. So 0 plus 0. Oops, went blue. 0 plus 0. K plus 1, and then we've got minus k plus 1, so the net here is 0. You've got a k and a negative k and a 1 and a negative 1 there. Now in this position, we've got k squared, and then we've got negative 2, well, let's see here. We've got k squared, negative 2k, so I'm going to write that down, negative 2k, and then if you distribute this negative 2, then you've got negative 2 and you've got positive 2 here. So when you combine those terms, the constant is 0 now. So we just have k squared minus 2k in this entry here. And then k plus 1 minus 1, so just k in this position here. So I'm going to move over and copy that into row 3. I went ahead and copied rows 1 and 2 the way they were. And so this row is 0, 0, k squared minus 2k, and then k in that last position here. Okay, now that we've got the reduced form, the question in problem 3 asks, first, find the values of k for which this system has no solution. So a system has no solution when the pivot is when you have a pivot in the constant column. So if we had a pivot way over here. So remember, a pivot is the first non-zero entry in each row. So there's no solution if k squared minus 2k is 0, so that we can have the pivot in that last column. So we need that to be 0, and we need k to not equal 0, because the pivot is always a non-zero entry. Well, this factors as k times k minus 2 equals 0. So k equals 2 is one solution to this equation. K equals 0 is the other solution, but we need k to not be 0 in order to have a pivot in this position here. So there's no solution only when k equals 2. Note that this last row will be 0, 0. You'll have 4 minus 4 here, so 0, and then 2, which would mean the last row is telling you 0 equals 2, which signals an inconsistent system. Now, so that's A. In B, we're asked, I'm going to move up here, to find the values of k for which this system has infinitely many solutions. There are infinitely many solutions when there is a column that does not contain a pivot. So one of these variable columns that does not contain a pivot. We already have a pivot in column 1 and column 2, so we would need column 3 to not have a pivot, which would mean that x3 is a free variable, which will generate infinitely many solutions. So we need, let's see. So we have infinitely many solutions. If there is a column without a pivot, I mean, in this system, it's going to mean that there's a row of all zeros at the bottom. So infinitely many solutions if k squared minus 2k equals 0 and k equals 0. And so k equals 0 satisfies both of those equations. If k is 0, then 0 minus 0 does equal 0. So we've satisfied this equation and this equation when k equals 0. Okay, so lastly, there is a unique solution, or a single solution, when each of these variable columns has a pivot. So it has a single solution if we have a pivot in this position here, which would mean we need k squared minus 2k to be non-zero. And then this k over here could be anything. It could be 0, it could be non-zero. But the important thing is that we have a non-zero entry in this position here. So remember, this is k times k minus 2. We need that to not be 0, which would mean k cannot equal 0 and k cannot equal 2. Any number other than 0 and 2, if we substitute for k, we'll have a system with a single solution.